Welcome to Teleforum, a podcast of the Federalist Society's practice groups. I'm Dean Reuter, Vice President, General Counsel, and Director of Practice Groups at the Federalist Society. For exclusive access to live recordings of practice group Teleforum calls, become a Federalist Society member today at fedsoc.org.
Welcome to the Federalist Society's virtual event. This afternoon, June 29th, we continue our Talks with Authors series with Dr. Stephen E. Koonin's new bestseller, Unsettled: What Climate Science Tells Us, What It Doesn't, and Why It Matters. My name is Evelyn Hildebrand, and I'm an Associate Director of Practice Groups at the Federalist Society. As always, please note that all expressions of opinion are those of the experts on today's call. Today, we are fortunate to have with us Dr. Stephen E. Koonin and Professor Diana Furchtgott-Roth, who will moderate our discussion. Professor Furchtgott-Roth is an adjunct professor at George Washington University, where she teaches economics. She is the former chief economist at the U.S. Department of Labor, and she is a senior fellow at the Manhattan Institute for Policy Research. Professor Furchtgott-Roth is also an executive committee member of the Federalist Society's Administrative Law and Regulation Executive Committee. After our speakers give their opening remarks, we will turn to you, the audience, for questions. So be thinking of those as we go along and have them in mind for that portion of today's event. If you do have a question, please enter it into the Q&A feature at the bottom of your screen. We will not be looking for questions in the chat, so please enter those questions into the Q&A. With that, thank you for being with us today. Professor Furchtgott-Roth, the floor is yours.
Thank you very much. I want to thank the Federalist Society for sponsoring this, and I would like to thank Dr. Koonin for talking to us about his new book. Well, Steve Koonin is the university professor at New York University. He is at the Stern School of Business, the Tandon School of Engineering, and the Department of Physics. Well, that sounds like 3 jobs to me, but apparently he can do all 3 at once. He was Undersecretary for Science in President Obama's Department of Energy from 2009 to 2011, where his portfolio included climate research. Before that, he spent 5 years as chief scientist for BP. He spent 30 years as professor of theoretical physics at Caltech, including a stint as a dean. He has a BS in physics from Caltech and a PhD in physics from MIT. Well, Steve Koonin is the author of Unsettled. Unsettled: What Climate Science Tells Us, What It Doesn't, and Why It Matters. And one of the things that was most remarkable to me about this book was that I could not get hold of it. Usually when I order a book from Amazon, it comes in 2 days. Well, they told me it was delayed. And then it was delayed some more. And then it was delayed some more. The demand for this book was completely not forecast by the publisher, who only published 15,000 copies. Now it's a bestseller. And my copy only arrived on the 21st of June. But fortunately, this has given me plenty of time to read it. And another thing that impressed me is the graphs that are very, very clearly explained. I mean, I'm opening just at random pages. I don't know if you can see, but there's very nice graphs there. Very well explained, very well annotated. So not only is this book in very good English, so you don't have to wade through equations and a lot of scientific terms, but everything is very nicely laid out in the graphs. And also the graphs are all sourced. So if I wanted to, I could go and try to reproduce them. So with that, I'm going to turn it over to Steve. And any questions you have, please put in the Q&A, because I'm not capable of reading the Q&A and the chat at the same time. So with that, I'll turn it over to Steve.
Thank you very much, Diana. It's a pleasure to be speaking with you and members of the Federalist Society today. It's very difficult to talk about scientific matters without showing some graphs, data, as Diana mentioned. And so I'm going to go through a bit of a presentation for you, telling you about the book, about the rationale for writing it, and giving you a taste of what's there. I assume you all can see the charts at this point.
Yes.
Very good. So the title I've chosen is Unsettling Climate Science, and that word unsettling is meant to be both an adjective and a verb. An adjective because some of the science I'm going to tell you about might unsettle your thoughts, because it is in fact quite contrary to the narrative most non-experts have heard. It's also a verb because I mean to unsettle that narrative by getting you all exposed to what the actual science says. Climate and energy are front and center today in both the political, the business, and the research agenda. We have seen the average global temperature anomaly go up by about 1 degree Celsius since 1900. And one of the questions, of course, is why is it doing that? And how are these temperatures and other phenomena associated with the climate changed in the recent and distant past? We'd like to know how the climate is going to change in the future under natural and growing human influences. Humans influence the climate most importantly by adding carbon dioxide to the atmosphere. It's been going up steadily, largely due to growing fossil fuel use. And of course, we would like to know how these changes are going to impact ecosystems and societies. And by the way, looking at this graph of the global temperature, you can already see that things are perhaps not quite as simple as you might imagine, since the temperature actually went down for about 30 years from 1940, even as greenhouse gases in the atmosphere grew. So it says that there are several different influences here that one needs to understand. And of course, the bottom line in all of this is how should society respond? What should we do about this situation? I'm a scientist, and I've had a lot of experience in providing scientific input to policy decisions. And I've come to understand that whatever I might say about scientific certainties and uncertainties, about many different subjects, dirty bombs, the Human Genome Project, things I've had experience with, ultimately the policy decisions are informed by the science, but are not determined by them, because the policies ultimately express values and priorities, which have to do with things well beyond the science. Nevertheless, this administration has placed a lot of stock in climate science. President Biden's executive order on Inauguration Day said, "It's the policy of my administration to listen to the science." John Kerry, who is the special envoy for climate matters, Ambassador Kerry, has said in the past, "Let there be no doubt in anybody's mind that the science is absolutely certain." And we have a number of distinguished political people like Bernie Sanders, Mark Carney, who was former head of the Bank of England, Bill Gates, my good friend Ernie Moniz, former Secretary of Energy, all using the words existential threat, climate crisis, climate emergency, climate disaster. Well, what is the science that they all keep talking about? There are a series of reports put together by the UN and by the US government that periodically assess and summarize the science for non-experts. The UN has the Intergovernmental Panel on Climate Change. Its fifth report was issued in 2014. The next one will come out on August 9th of this, in a few months from now. The US government is mandated by Congress to produce every 4 years a national climate assessment. The fourth one of those came out in 2017 and 2018 in two parts, and the fifth one is expected in 2023. These reports, when you read them, say important and sometimes surprising things. But I can guarantee you that almost anybody on the previous page, those photos that I showed you, has not read these reports, or perhaps even the summaries for policymakers. And the reason I can say that is because you really need to be a scientist and have studied the matter in order to understand what the reports say. I would, by the way, perhaps exempt Ernie Moniz, who is a physicist and could well have read these reports. But if he did, as you'll see, I'm surprised that he keeps talking about a climate crisis. When I hear people talking about the science justifying a climate crisis or sweeping action, I'm reminded of a movie from The Princess Bride. In that movie, one of the characters, Vizzini, the bald guy on the right there, keeps using the word inconceivable. And the principal character, Inigo Montoya, at some point says, "You keep using that word. I do not think it means what you think it means." And in this context, I would say, I don't think the science says what you think it says. And in fact, when you read the reports, there are some surprises. For example, heat waves in the US are now no more common than they were in 1900, and the warmest temperatures have not risen across the 48 lower states in the past 50 years. And I'll give you a reference to the report and the exact figure where you can see that. Global wildfire area has declined more than 25% in the past 17 years, and 2020 was among the least active years in the wildfire record globally. Greenland's ice sheet isn't shrinking any more rapidly today than it was 80 years ago, when human influences were less than 20% of what they are today. And there's been no detectable human impact on hurricanes over the past century. And finally, most important, surprising to me, and maybe most important in some sense, a bottom line, is that the net economic impact of a global warming of 6 degrees. Remember, we've already seen one. The Paris Accord is trying to hold the warming to 1.5 or 2 degrees. So this is much larger than anything those folks are talking about. The net economic impact will be minimal. And I'll show you that in a little bit of detail in a moment. Statements like these and many others you can find in the report really belie the notion that we've already broken the climate and face certain disaster unless we act promptly on an enormous scale. You could ask, how did the science in the reports get turned into the science? And the answer, I think, is that there's a long game of telephone that goes on. It starts with the observational data and the research literature, which is really quite good. It goes to the assessment reports that assess and package that data. It goes then to the summaries of policymakers in those reports, which have the heavy hand of government in what they say and how they say it. And then you get to the media and the decision makers and the public. And when you go through this long chain of telephone, there's much bad behavior along the way. People confuse weather with climate. Weather is a multi-decade average. Climate is a multi-decade average of weather. Weather is what happens every day. Climate is its average. They confuse climate change, which is change associated with human influences, with a changing climate, since the climate changes for many reasons. You get a highlighting of recent trends without providing historical context. If it happened before, when human influences were small, you at least had better explain why it happened before you say current events are associated with human influences. Extreme scenarios for the future are termed business as usual. Uncertainties are minimized. Alarming predictions are made and soon forgotten. We have reporters and non-expert activists who are aiming to persuade the public and decision makers rather to inform them. And finally, it's something I've experienced recently. There is suppression of legitimate divergence from the narrative, use of the words like denier. I wrote the book to try to get people a view of what's in the reports without having to go through all these filters and give them some accessible sense of what the science really says. I'm going to go through 2 examples. One is tropical cyclones, also called hurricanes. If you look at the 3rd National Climate Assessment, you see these graphs, and particularly the one on the left, which is some measure of hurricane activity in the North Atlantic from 1970 up to 2010. And they draw in a trend line for you. And boy, it sure looks like things are getting a lot worse, at least in that part of the ocean. But if you actually put that graph in context, so that's the black here is what's shown on the report graph, you can see that it went down and then went up again. So that's an example of not telling the whole truth, perhaps. And in fact, if you look at the longer record or more detailed record of hurricanes, you can see that since 1970 up to the present, December of 2020, which was the end of last year's season, there's no change at all in the number of hurricanes globally. And if you look at some measure of hurricane activity, it's got lots of ups and downs, including last year's very active season in the North Atlantic. The official reports say that there's low confidence that there's any long-term trend in hurricane activity. And a recent paper with 11 expert authors said that the majority of the authors had only low confidence in any other observed change in tropical cyclone activity that could be detected or attributed to human influences. The one change they did identify was a very slow poleward migration of some hurricanes in the Northwest Pacific. Okay, one more example, and then I'll try to sum up and we'll go to discussion. Let me talk about the economic impact of warming. And this, to my mind, is one of the most misleading aspects of this whole business. If you look in the U.S. government assessment report in 2018, a key finding was climate change is projected to impose substantial damages on the U.S. economy, health, and environment. Under scenarios with high emissions and no adaptation, annual losses are estimated to grow to hundreds of billions of dollars by the end of the century. And they give us this detailed table of economic damages in 2090 under a high emission scenario and under a low emissions scenario for labor, coastal property, accurate to 3 significant digits for a projection 70 years out. A little remarkable and not something that would have passed peer review in any paper I looked at. Nevertheless, we get all these headlines that were issued upon the release of the report. NBC News says climate change will wallop the U.S. economy. Climate report warns of grim economic consequences. Climate change could cost the U.S. billions. New York Times weighs in, of course, with an alarming headline. Well, the root of all of this in the report is a graph that shows the percent damage to the U.S. economy as a function of the temperature change around the globe. And this is in 2090 relative to 2000 or 1990. And you can see that as the globe warms, the damages are projected to increase, but even for a temperature change of 9 degrees Fahrenheit, which is 5 or 6 degrees centigrade, depending on how you measure it, we're looking at 4% hit on the U.S. economy in 2090. When you look at that and you actually understand it, you discover it's actually at worst a bump in the road. And I published that in a Wall Street Journal op-ed a couple years ago. In fact, in the UN report, it says the impact of climate change will be small relative to the impacts of other drivers like population, technology, regulation, and so on. You can look at that for the U.S. explicitly. This is the real U.S. GDP. Since 1930, it's gone up by a factor of 20, which is amazing, even as the population has gone up by a factor of probably 2 or 3 since 1930. Here's the real annual growth rate for the U.S. GDP. It averages about 3%. The OECD says that looking over the next 40 years, the growth rates for the U.S. economy will be about 2%, and for the world, slightly more. So if you just take those numbers and plot what the US GDP will look like starting from now and going to 2090 at a nominal 2% growth rate, you get the blue curve. But if you take the climate impact of an unprecedented and unpredicted, actually, warming of 5 degrees, you get the orange curve. And if you take even a 10% impact, you get the gray curve. In other words, the climate-induced damages amount to a delay of a few years of growth by 2090. And of course, nobody can predict with any precision that far ahead. So I would love to ask some of those folks on the first slide I showed you, is this the climate crisis? And if it isn't, please tell me what is. Okay, let me not go through these takeaways because we're running short on time. I think you've got it largely from what I've said, but I want to do just a minute or two on the administration's goals and plans to reduce greenhouse gases. The goal is to reduce net greenhouse gas emissions for the country by 50% relative to 2030. And there I show you a graph of what U.S. annual greenhouse gas emissions will look like, and an aspiration to get to U.S. net zero by 2050. The power sector is meant to go to net zero emissions by 2035, and you can see this blue line over here about how it has, in fact, been going down, largely because of the switch from coal to natural gas, and then a bit because of the growth in wind and solar. They want to eliminate vehicle sales of gasoline and diesel-powered cars by 2035, 15 years from now. Restrict new domestic U.S. oil and gas production, and basically have been infusing climate risk into all aspects of the federal government, especially in financial matters. But it's worth bearing in mind a couple of facts. Oil and gas employs about 10 million people in the U.S. and accounts for 8% of the GDP. There are about 1,800 fossil-fueled power plants in the U.S., and if you want to make them all go away in 14 years, you're going to have to decommission 11 per month, which is an astounding rate. There are about 280 million gasoline or diesel vehicles on the road that all have to be done away with. And so that raises a number of concerns. The pace and scale that is being proposed will degrade reliability of the electrical grid, particularly with the added burden of powering electric vehicles. We're going to see destruction of asset values, the fossil fuel plants, the fuel infrastructure, and the vehicle infrastructures. Fission, nuclear power, is going to be essential to getting to an emissions-free grid. We have not been deploying nuclear facilities at any rate at all over the last 20 years. The storage technologies that would back up wind and solar power just don't exist yet. Energy insecurity is going to grow. As we curtail domestic production, we'll rely on the Mideast and Russia more for our oil and our gas. So I think as these measures start to impact real people, there could well be a citizen backlash, very much like the Yellow Vest demonstrations or the UK heat pump fiasco that we saw a couple of months ago. And anyway, the US is a shrinking fraction of global emissions. It's only 15% currently and getting smaller as the rest of the world emits more. And so if US emissions were to go to zero tomorrow, it would be negated by a decade's worth of growth in the rest of the world. And so people are going to be asking, tell me again why we're doing this. And I think people had better come up with a good answer, lest the whole thing be slowed down, if not stopped entirely. Okay, last chart. I aspire to be the anti-Gruber of climate science. Jonathan Gruber, an economist at MIT. Diana, I'm sorry to keep dumping on economists.
It's okay. It's okay. We deserve it. We deserve it.
All right. Okay. Jonathan Gruber was one of the architects of the Affordable Care Act. And at some point after it was all over and passed, he said in a seminar, a lack of transparency is a huge political advantage. It was really, really critical to getting the Affordable Care Act passed. At least one key provision was a very clever basic exploitation of the lack of economic understanding of the American voter. And, I happen to be a big fan of universal health care. So my criticism is not about the act itself, but about the tactics, misrepresenting the science to persuade rather than inform is so antithetical to what we scientists aspire to. In this case, it usurps the right of the public to make fully informed decisions, to trade all of the values considerations against scientific certainties and uncertainties. It distracts from more urgent needs. We have so many more urgent problems in this country than worrying about a threat that might be a threat, actually, a generation and half a world away. It tarnishes scientific input to other important policy matters, and COVID comes to mind most immediately. And finally, it depresses young people to the point where they believe they only have a decade to live and are not having children and so on. And, that last, I think, is really immoral. And I would fault many of my scientific colleagues for over-egging the custard. So that's why I wrote the book, to try to mitigate some of the bad behavior that's been going on as we talk about climate and energy. And with that, I think I'm done. And I'm happy to have discussion or questions and answers.
Well, thanks very much, Steve. That was really illuminating. Let me start with a couple of questions before we go to the Q&A. And let me just say, any of you have questions, please put them in the Q&A. And then we're going to get to them. But here's my question, my first question. The temperature in Canada hit 150 degrees this week. According to the Washington Post, and I'm quoting from yesterday's Washington Post, the high temperatures in the region have been blamed on a, quote, heat dome, a sprawling area of high pressure, now sitting over Western Canada and the Pacific Northwest. Experts say climate change can make extreme weather events like this more common, unquote. Steve, is climate change creating these high temperatures in Canada? And if so, what should we do about it?
Yeah, well, as usual in climate matters, the answer is a little bit complicated. And so I want to take you through a couple of statements and some reasoning. First of all, we have to remember the distinction between weather and climate. Weather happens every day. Climate is the multi-decade average of weather. So what happens in 1 year or even in a few years is weather. However, if we saw this kind of thing several times over the coming decade, then it starts to be climate. The World Meteorological Organization reminds us that any given weather event cannot be attributed to climate change, but a changing climate does shift the odds. With respect to the temperatures, the globe as a whole has been warming since 1700 as it came out of the Little Ice Age. And so it's not surprising that it's continued to rise in the 20th century. As I mentioned right at the beginning, human influences are playing a role in this long-term temperature rise, but exactly how much is unclear. And I would also remind people, if they don't know, that 125,000 years ago, the last interglacial, called the Eemian, the globe was 2 degrees warmer than it is today, and sea levels were 6 meters higher. Now, with respect to the weather episode in the Northeast, it's regional, first of all. It's due to an unusual but not a known combination of factors. There's a high-pressure dome, as you mentioned, and at least in the Pacific Northwest, it was interacting with a low-pressure trough, unrelated phenomena. But the combination sent the air westward down the Cascade Mountains, where it got heated as it descended and created the unusually high temperatures. It's scientifically interesting, but one event can't say whether you've tipped the odds or not. So I'm sure everyone will be watching to see what happens over the next few years.
Well, thanks very much, Steve, for that illuminating response. Our first audience question comes from Lee O'Connor of the Federalist Society, and she wanted to know, what was the UK heat pump fiasco? And in fact, I don't even know what it is either. So what is it?
Okay. So it's a wonderful example of the non-expert regulators getting way out over their skis. The UK, as you know, aspires to be net zero by 2050 or something like that. And an important part of what they need to do is to reduce energy use in buildings. And as I teach in my class at NYU, they had a couple of trials in council housing, row houses, and it turned out to be enormously expensive and not very effective, largely because the improvements or retrofits have to be bespoke, and it gets really expensive. Anyway, the heat pump fiasco was an attempt by the government to mandate that gas boilers for heating houses be disappeared, vanished by some time frame, a couple decades, I think, and would be replaced by heat pumps. Heat pump is an electrical device that basically runs like an air conditioner in reverse and can take heat from the outside and put it into the inside of your house. Heat pumps come in two kinds: air-sourced heat pumps, where they get the external heat from the air; ground-source heat pumps, where they get the external heat from a well in the ground or a hole in the ground. Typically 15,000 pounds, I think, for a ground-source heat pump. Anyway, this is a substantial expense mandated on homeowners, and there was such an outcry that the government had to walk it all back, I think, within a week of having announced it. So I don't know what they're doing right now, but again, it's a great example of aspirations by non-experts who don't think about the economic or technical issues at all.
Well, thanks very much. Our next question comes from Tom Fleming. He says, most of the predictions associated with climate change rely on models used by the IPCC and other agencies and organizations. By all accounts I've seen, these models employ a very large number of interdependent variables. My experience in modeling is that accuracy degrades exponentially with an increase in the number of variables used in the model. Could you address this and either support or debunk these climate and associated economic models?
Yeah. Models are important for climate science. They help us understand the processes by which the climate works and how those processes interact with one another. A typical climate model, I'll get to the economic models in a minute. A typical climate model covers the Earth with 100 million boxes. Say, 100 million boxes. Some of these boxes extend up into the atmosphere and more go down into the ocean. And then it uses the basic laws of physics to move energy, humidity, radiation between these boxes at 10-minute time steps, and one needs to do that for 100 years or more. So it's a massive computational undertaking. There are many problems in the modeling, but probably the most fundamental one is that the boxes, for practical reasons, can't be smaller than, say, 60 miles on a side. If they got smaller, you'd have far too many of them. But many important phenomena in the climate system happen on much smaller sizes. Think about thunderheads, for example, so-called moist convection in the tropics, which is very important. And so you have to make assumptions about what goes on these subgrid scales. Different people make different assumptions, and so you get different answers in the models. There are many other problems I could go into if we had time, but modeling is more of an art than a science. And the models, as they have become more sophisticated, have also become more divergent with one another and with the data. Probably because as you add more degrees of freedom, interdependent variables, the opportunity for things to go wrong just increases. And as you say, the accuracy degrades exponentially. They're working on it. It'll be very interesting to see how this next generation of models is described in the report to be issued in August. Now, when you get then to the so-called integrated assessment models, which include the economy together with the climate in an interdependent way, as I once joked to a very prominent economist who shall remain nameless, but whose name you would all know, I said, these integrated assessment models are a doubly dismal science because you've got the uncertainties in the climate as well as the uncertainties in the economics. So I don't put much support in them. And even that few percent number that I quoted for you from the report on economic impact, I would say there's tremendous uncertainty in that. But nevertheless, it's what the official report, reviewed by thousands of scientists, et cetera, says. So we should probably take it seriously. I would have loved, as some of you may know, I would have loved to have red teamed that report. It's got so many problems with it, but that's a different discussion. Yes.
Can you explain to us why criticism of these models is such a sensitive topic? I once had a young man at my dinner table. He was a physics associate, he was a physics professor at MIT. He told me these models were hardly worth anything, that their predictive powers was very low. But he couldn't say it, he couldn't write about it, or he would never get tenure. Why is it that it's so difficult to criticize these models?
Let me start by saying what I think is the grand strategy that the climate industrial complex is pursuing. If you want to get action on something that infuses all of society as important to everybody, which is energy, you can't look at the past. You've got to frighten people by looking at the future. I like to quote H.L. Mencken, it's in the book, who says the purpose of practical politics is to keep the public alarmed by a series of mostly imaginary crises so that they're clamoring to be led to safety. The only way that you can project the need to act is by looking at the future. And so it's these models. So they're central to the strategy, if you like. But anyone who has built models treats them with a good deal of skepticism, as I try to outline in the book. So that's why you can't criticize it, because it is a linchpin of the consensus strategy to induce action.
Well, it's troubling that so many people are in league with this, that even this young, very brilliant man was concerned about his academic future.
So here's an interesting anecdote. I think this in the book also. Again, the person involved shall remain nameless. But when I first started to come out with my doubts about 7 years ago in a Wall Street Journal op-ed, the head of a very prominent earth sciences department in the U.S. said, Steve, I agree with about everything you wrote, just about everything you wrote, but I dare not say it in public.
And you were interviewed in the Wall Street Journal, and the article finished with a mention of your daughter saying how she was glad that she's married and had another name, so people wouldn't be able to, she wouldn't be tarred with your views. So, yes, even members of your family.
Right, exactly.
Yes.
Yeah.
Well, let's go on to the next question from Doug Greenhouse. Doug wants to know, where can I read and understand the connection between any given, quote, strategy, unquote, and average temperature increase? For example, if all new vehicles sold in 2030 were electric vehicles, what would be the effect, all other things being equal?
So the answer to that question combines two numbers, one of which we don't know very well, the other of which we know well. The number that we don't know well is the sensitivity of the climate to greenhouse gases. In other words, and a common measure is how much would the temperature go up if we were to double the carbon dioxide concentration from its pre-industrial value. And the models, the famous models we talked about, are all over the place on this. They go from a 1.5 degree increase for doubling CO2 up to some of the most modern models, 6 degree increase for doubling CO2. So we're quite uncertain about how sensitive the climate is. But what we can do is to say, if all electric vehicles were to disappear, let's say if we stop selling them by 2030, they'll probably all be gone off the road by 2050. And so we could ask, if we stopped emissions from road vehicles, how much of a reduction in greenhouse gas emissions would we have? And remember, we have to do this for the globe as a whole. It doesn't help if just the US does it, because the CO2 is a global commons, if you like. So I think all of transportation at the moment is about 25% of energy-related emissions. So we would reduce emissions by 25%. But that doesn't reduce the concentration, which is the thing that affects the climate, and is the cumulative emissions. So it would delay crossing any given danger line, but it wouldn't prevent it. We have to go to global zero if you want to just stabilize CO2 in the atmosphere.
That's going to be very difficult from the point of view of these developing countries that want to catch up with the West. They are not going to be able to build Western-style economies on wind and solar alone. And many of the people who are concerned about climate change do not like nuclear power, which is emissions-free. How do you think that we can manage to raise their standards of living at the same time as having a net zero greenhouse gases the way many people want?
You can't. Okay? You can't. And I say in the book, it's a practical impossibility to eliminate global emissions. And the factor you just cited, the need for energy by the developing countries, is probably the biggest barrier to that. Let me remind people that 40% of people on the globe right now, so that's 3 billion people, do not have adequate energy. And the most reliable and convenient way of getting them that energy is through coal and gas. That will also have other benefits. We will reduce the burning of wood and dung for cooking in houses, and reducing, therefore, the local pollution, which kills a couple million people a year. It's just awful. And in that sense, providing people with, let's say, propane for cooking is one of the most impactful health things we can do. We can't even run the whole US on wind and solar. You know, wind and solar are intermittent. They generate when they want to. We need electricity 24/7 reliably, and you cannot do that without some form of currently costly emissions-free backup. My own favorite is nuclear, in particular small reactors that are being developed. Other people like batteries, but the cost is just not there yet. They're still much too expensive, and the scale is almost unimaginable that you need.
So you devote a lot of time in your book. Well, you devote a couple of chapters to Plan B, and you don't just have one Plan B, you have a couple of Plan Bs. Given that it's going to be impossible to eliminate the greenhouse gases that many people want to eliminate, what is your Plan B?
Yeah, I think there are two, or maybe 2 and 1 plus 1, if you want to think about it that way. The most important strategy, and the one I think which will predominate as we discover how hard it is to reduce greenhouse emissions, is adaptation. It's something society does autonomously. We do it already. We're very good at it, at least in the developed world. Societies extend from Hudson Bay down to the tropics, and they're all well adapted to the climates that they experience. Adaptation is also here and now. You will build a higher seawall or change the crops, as opposed to paying for some amorphous threat that might happen a couple of generations from now halfway around the globe. So it's much easier to sell politically. The problem with adaptation is that, of course, developed countries are much better at adapting. They have the capacity to do it than developing countries. And so I think the strategy there is to strengthen the governance, the finance, the ability to plan and execute in these developing countries, which of course is a longstanding problem that we're all working to address in various ways and would have many other benefits besides climate. If the climate ever gets really broken, and I believe that has a very small chance of happening, we could resort to geoengineering. And these are methods whereby we intentionally intervene into the climate system, either by making the Earth a little bit more shiny. All you have to do is make it 1% more shiny to counteract the effect of CO2 that's been emitted so far. It happens naturally. When a big volcano goes off, like Pinatubo did in 1991, it puts particles up into the stratosphere that linger for a couple of years, and they demonstrably cool the planet. And we could do that artificially. It wouldn't be very expensive. There are, of course, great concerns about doing something like that. And so I think we need a lot of research to discover whether we even have that tool in our pocket, and then maybe some small-scale demonstrations. And there are people, David Keith at Harvard, for example, who's working on that. The other plan B is to suck carbon dioxide out of the atmosphere. I'm not going to go into the details of the carbon cycle right now, but just remark that planting more vegetation will, in fact, suck more carbon dioxide out of the atmosphere. We could also try to do that artificially, but right now it's pretty expensive. Again, people are trying to do that commercially. When I look at the cost and scale and the time it would take to have a material impact on the climate, I'm not very optimistic about that one.
Well, thank you. Thank you. Let's go to another question from Jay. Jay is asking, would you please elucidate on where pro-AGW, which I assume means global warming scientists, and skeptical scientists agree, and where they diverge? For example, do both sides agree that man is causing the vast majority of the warming? There are other factors besides CO2, so what about those?
Yeah, I think, and I actually moderated a discussion on this as I first got into the science deeply about 7 years ago. I had 3 consensus experts and 3 skeptical experts talking, and we said, let's see where we can agree. I think everybody's agreed that the globe has warmed by a degree, as I said, since the turn of the last century. I think everybody will agree that carbon dioxide is rising and that it is due to human burning of fossil fuels, mostly burning of fossil fuels. I think other points of agreement are that growing CO2 exerts a warming influence on the planet. By the way, it's about a 1% influence, so it's pretty hard to untangle from the other influences, which I'll enumerate in a moment. But I think people begin to diverge on just how much of that warming has been due to carbon dioxide, human carbon dioxide, as opposed to other factors, both natural and anthropogenic. The other important anthropogenic factor, human caused, is aerosols coming from the burning of dirty coal, for example. They exert a cooling influence that's about half as large as the warming influence of carbon dioxide. And it's kind of difficult to untangle both of those, one from the other. There are other natural influences. The volcanoes, that's pretty easy to understand and see in the record. But there are long-term cycles in the climate system that the models do not reproduce or capture at all very well. The most familiar of those is El Nino, happens every 4 or 5 years, 5 years. The models actually do a pretty good job on reproducing those. But there are other cycles that take 60 years or even centuries such as what's called the Atlantic multi-decadal oscillation, the Pacific decadal oscillation. The models do not have those at all, and they influence the global temperature. And unless you've got them in your models, you're not going to do a good job of extracting the sensitivity. And so while the consensus might say, in its last report, we'll see what it says now, at least half of the warming since 1950 is due to human influences, it relies on those models. And so some of the more skeptical people will say it's probably even more uncertain than that 50% number.
Well, thanks, Steve. The next question is about the benefits of warming. It's from David Simon. He says there's important evidence that a warming planet is beneficial, but this evidence is generally ignored. For example, a study published in 2015 by The Lancet found that cold kills over 17 times more people than heat. This study, quote, the largest data set ever collected to assess temperature health associations, examined more than 74 million deaths in Australia, Brazil, Canada, China, Italy, Japan, South Korea, Spain, Sweden, Taiwan, Thailand, and the United Kingdom and the United States from 1985 to 2012. The study reported that cold temperatures were associated with 7.29% of those deaths, while heat caused only 0.42%. David says, I hope you and other climate scientists will start highlighting points like this. Well, do you agree with this study? Is this one of the studies that you think is real science? Do you agree with it? Should we start highlighting it? I know people have more colds and flu in the winter than in the summer.
Right. People do not die from climate. They die from extreme weather, as you pointed out, cold snaps or heat waves. And if society is well prepared for them, then the deaths are minimized. If you look at the deaths in Chicago, for example, before air conditioning became common, they were much higher than they are today. With respect to highlighting solid studies, and I don't know this particular study, or at least I haven't looked at it in detail, but I know, after all, it's in the Lancet. How could it be wrong?
Actually, the Lancet is not the gold standard.
Yeah. Okay. Thank you. A lot of people who don't know anything keep quoting peer-reviewed papers, et cetera, et cetera. And you've just, of course, highlighted a very important fact that all peer review is not the same. And even when it's peer review in a quality journal, you've still got to look very hard at it. And people who want to see good scientific input to societal decisions keep highlighting studies like this, studies about the points I raised in the beginning, some of the surprises I told you about that are in the reports, and they are just ignored by the climate, I won't use the word alarmists, but by the consensus. It's kind of a eyes shut, fingers in the ears mentality that is just so antithetical to either science or to making wise decisions. And I think eventually the public, even if they're not experts, have a lot of good common sense, are going to start to ask some very hard questions, but we're not there yet.
Yes, well, I think there already are. Some people are already asking questions, such as, why does this ugly windmill have to be, in my view, blocking my view?
Yeah.
Well, we have a follow-up question to this, and then I'll go back to an earlier one. Is it your position that mainstreamers you criticize are sincere but incorrect? Or is it that they know they're lying? If the latter, why are they doing it?
Gosh, there are several different players here. I think the media, if it bleeds, it leads. There are climate reporters who want to get their stories on the front page. There is an awful consortium of media outlets called Covering Climate Now. You can look them up on the web, which have all sorts of prominent broadcast and print media as members, and they have vowed not to publish anything that disagrees with the consensus. That's terrible. Okay? For the NGOs, if you've built your organization on a climate emergency, you're not going to start saying gee, this is maybe not as bad as we thought it was. And if you're an academic, well, some academics truly believe that they are saving the planet. Others see continuing funding, continuing prominence. They've staked their reputations on this. So it's a little bit hard to acknowledge that the science may not be as settled as people think it is.
Well, speaking of settled science, Diana Weisick wants to know, what then is the goal of the consensus energy strategy?
Well, the tangible goal is to eliminate greenhouse gas emissions by 2050 or 2075 globally. Okay, that means not only in the US and the EU, the rest of the developed world, but more importantly in China and India, Indonesia, Brazil, and so on, which is in some ways where the real emissions problems are, to the extent you believe that there are problems. But there are other, energy strategies. Another is, if I'm looking to build a new business and overturn established order, it's a lot easier to get a mandate for wind or solar and help me get my business started. More than a mandate, maybe subsidies. So I think there are a lot of entrepreneurs who have moved into this space as well. And then there's just a lot of virtue signaling. If you ask some of the prominent financial people or the politicians, did you really read the report? And here it says it's minimal economic impact. Why are we making such a big fuss? I don't know what they would say. It'd be very interesting to ask that question.
Well, we have a question from an anonymous attendee who wants you to talk a little bit more about nuclear power and recent technological advances in nuclear plant development.
Yeah.
And I think this will have to be the last question, given that we are supposed to end in 2 minutes.
Okay.
This is the last question.
Nuclear power is the most reliable, dispatchable, namely you can turn it on and off, source of electric power we have that is emissions free. The world builds, at the moment, large nuclear plants that generate about 1 billion watts of power for each core of the reactor, and sometimes there are a couple cores on a site. Its downside is it takes a long time to build because of regulations, safety requirements. But the upside is once it's running, it takes very little cost to keep it running. So large capital upfront, small operating expense.
And doesn't France generate 70% of its electricity from nuclear power?
That's correct. Absolutely. In Japan, 30%. It used to be before Fukushima, then they went down, but it's now starting to come back up again. If we can build small reactors, what are called small modular reactors, which the government from even the time I was there was trying to promote, then we could build them in a factory rather than individually built as we do in the US. We could truck them to a site on a flatbed truck or a rail car. We could install them in a standard way. You put the first one in, it starts generating a cash flow that helps you finance the second and the third and so on. So we've got to get these small ones licensed, and there are applications before the Regulatory Commission now, and then start to come down the cost curve. I don't see how we get to a zero emissions grid unless we do that.
Sounds especially beneficial for the developing world.
Absolutely.
Which has very little other source of energy.
There are proliferation concerns, of course, nuclear weapons proliferation, but I think those are quite manageable with the right arrangements.
Well, on that note, I want to thank you so much for taking the time to speak to us today. And I highly recommend the book. It was worth the wait. It took about 6 weeks for it to arrive from Amazon, but I understand now they have plenty of copies in stock. And it makes a great read and a great gift for your favorite environmentalists. Thank you very much. I'll turn it back to you.
Thank you, Diana, for great questions, and thanks everybody for listening.
Thank you both for such a great discussion. That was fascinating. And on behalf of the Federalist Society, I want to thank both of you for the benefit of your valuable time and expertise today. And I want to thank our audience for participating and sending in excellent questions. We welcome listener feedback by email at info@fed-soc.org. As always, keep an eye on our website and your emails for announcements about upcoming teleforum calls and virtual events. And today I think we have 3 additional events coming up. The next one is at 1:30, Navigating High-Profile Defamation. So check your emails and our website for that information. Thank you all for joining us today. We are adjourned.
Thank you for listening to this episode of Teleforum, a podcast of the Federalist Society's practice groups. For more information about the Federalist Society, the practice groups, and to become a Federalist Society member, please visit our website at fedsoc.org.